My name is Yang Junxiang. Today's topic is about magnetism and ferrofluid. Magnetism is basically the nature of the material and how it reacts to magnetic fields. For today, I will briefly talk about the most common three. The first is ferromagnetism, which have persistent magnetic moments that create magnetic fields on their own, most commonly seen in iron, nickel, and cobalt. When a magnetic field approaches, the magnetic moments align so that even when the magnetic field is removed, they are still aligned to create a large enough magnetic field that we can see with bare eyes. Next, we have paramagnetism, which have magnetic moments that can freely align itself in any direction. When applied to a magnetic field, they can align accordingly, making the material slightly attracted to the magnetic field. When the field is removed, thermal motion randomizes the magnetic moment. Last of all is diamagnetism. Opposite of paramagnetism, it aligns in the opposite direction, making it repelled from the magnetic field. Now I'm going to talk about ferrofluids, which is made of nanoscale ferromagnetism materials covered in special fluids. As you can see, they are strongly magnetized by magnetic fields, creating all the spikes you see. Yet because the nanoparticle properties of ferromagnetism are too weak to remain after the magnetic field is removed, ferrofluids are often classified as paramagnetism. Because its magnetic and liquid properties, it is widely used for high-end machinery. Thank you for listening.
Hello everybody, I'm Zheng Hao. I want to introduce levitation. Levitation is magnet repelling each other to make objects floating in the air. The common application is the magnetic levitation chain. The magnetic is used to the magnet repulsion and the attraction to let the train floating in the air. And then it will let more fast and more stable. The track is divided into two. The one is used to repulsion, like this. The red is electromagnet. It use it to repulsion the train, let it floating in the air. And the other one is used to attraction, like this. Use the electromagnet to let the train floating in the air. Now I will introduce another levitation application, like this maglev jewel. There is a ring magnet in this jewel, and there is a ring magnet in the disc. Now I put the jewel in the center of disc and give it an angular momentum. Then lift it slowly. When I find the gravity is equal to the magnetic force, it will rotate in the air. So the jewel will rotate in the air rotate more long than on the disc, because the resistance in the air is more small than the friction on the air on the disc. This is my report. Thank you.
sensing. Have you ever heard the so-called electronic compass? In the compass, there are elements sensing the terrestrial magnetism. By calculating the resistance of the elements, we can know the strength of the terrestrial magnetism. By calculating the resistance of the sensing elements, we can know the size of the applied magnetic field, and then calculate the strength and direction of the Earth's magnetism. Elements' resistance will change with the variation of magnetic field, and from low to high, we divide them into 3 types according to their sensitivity in resistance changes. The first type of elements is based on Hall effects. In short, in a conductor, moving electrons are affected by Lorentz force, and their resistance changes. The second type is to use AMR. In magnetic material, the resistance is related to the angle between the electric current and magnetic field. The third type is to use GMR. In brief, even though the strength of magnetic field is very tiny, with the GMR we can find the dramatic change of magnetic conductor's resistance. Because of the strength of terrestrial magnetism, we must eliminate all the magnetism field interfering the elements. After our eliminating, we can calculate the accurate strength of terrestrial magnetism. Next step, with the value of the terrestrial magnetism in X and Y sector, we can easily know our position. Thank you.
Hello, my name is Li Jingyan. I want to introduce the electron spin. Electron spin is very different. It only has 2 values. One is 1/2 and the other is -1/2. And in normal condition, the resistance will not different, but in the magnetic field, it will very different. If I call the 1/2 spin is up and the other is down, the up spin will have the small resistance, and down spin will have the large resistance. We call this magnetic resistance, and we can use this in drive. Our drive's head has a read and write head. Read, we use the electromagnetic induction to drive the signal 0101 into the disk. And in reading, we use the giant magnetic resistance field effect to detect the 0101 signal to our computer. Over.